So now let's solve. So this is a review in solving using zero product property to solve for the variable. So what we're supposed to do in this case is we're going to set each piece equal to 0. So x plus 4 equals 0. And then x minus 9 equals 0. So when we solve for x for each of these, so for the left, we're going to subtract 4. And so when we do that, we notice that x equals negative 4 on the left. Then on the right, we're going to add 9 to both sides to isolate our x. So then we see that x equals a positive 9. So some of you will be able to do this without having to set it equal to 0. So you don't have to. If you can see it right away, that's totally fine. But notice that they are opposite signs. What this gives us are our x-intercepts. Okay, so remember we were graphing in intercept form. This is our x-intercepts of the graph. Okay, number 2, let's try this one. So it looks a little different. We have a in the front, so we're still going to set each piece equal to 0. So this is going to be a equals 0. Then on the right, that is going to be a minus 2 equals 0. So on the left side, that's already solved, a equals 0. On the right, let's finish that out. So we're going to add 2 to both sides. So the answers to this are a equals 0 and a equals positive 2. The last example is 3. We have 2q minus 5 and 4q plus 1 equals 0. So let's set each piece equal to 0. So in this case, it's not 5. We have to solve for it. So sometimes it's harder to see. Set each piece equal to 0. Then we solve for the variable. So on this side, we're going to add 5 to both sides. So we get 2q equals 5 divided by 2. So we notice that q equals 5 halves. Then for the right side, we're going to subtract 1 from both sides to start isolating our q. We get 4q equals negative 1 divided by 4. So in this case, q equals negative a fourth. So our solutions here are 5 halves and q equals negative 1/4. So if you can finish out number 4, 5, and 6, that would be great. So hopefully the samples above will help you out. Now let's just do factoring when a equals 1. So we'll take it a step further. So it's not in factored form. We need to actually factor it. So what we're going to do is we're going to use the x method. We notice that the coefficient of the x word is just 1. It is always a times c. Now because it's 1 on top, 1 times 30 is 30. Okay, so this is going to help us out when a is not 1. Then in the bottom, we know that that's always the b value, which is negative 17. So attic times ceiling, that's the a times c. And the bottom is negative 17. Again, this comes from ax squared plus bx plus c. And so that's where the a and the c come from at the top, and the b is the negative 17 at the bottom. So we look at what multiplies to 30 that adds to negative 17. So that is going to be 15 times 2. 15 times 2 is 30. But it needs to be a negative 17, so it has to be both negative. So if it's a positive a times c, then the signs have to be the same, and then the b tells you what sign it is. So it's negative 17, so this is true. Now what we're going to do is go ahead and factor it. So these are our factors. So we're going to write x plus 15, x minus 15. We write exactly what's there. X minus 15 times x minus 2 equals 0. Then we use the zero product property like we did earlier, and maybe you can see it already, is that x equals a positive 15 and x equals a positive 2. So remember, in order to do that, you just set each piece equal to 0 and then solve for the x. And that's how I get a opposite signed. Okay, so then number 8, let's do x squared minus 81. Now, if you remember, that's a difference of 2 squares, but if you don't, that's okay. We can still use the x method. So the numerator, we're missing a 0bx, or a 0x. So we're missing a b value. So the top is a times c, which is negative 81. There's no b value, so it's 0. So what multiplies to negative 81 that adds to 0? Well, we know that negative 9 times a positive 9, that gives us negative 81. So our factors in this case are x minus 9 times x plus 9, and it equals 0. So then the answer is x equals 9 and x equals negative 9. So I do want to see the factored form here because that is where we're headed. This chapter and, throughout the year. And so make sure that you show me this. I do not want to see, for example, that you just do this x method and then come down to here. You need to show me the factored form. Okay, so I hope this helps out in finishing out number 9, 10, 11, and 12.